What I'm gonna do?
Yeah, the palm trees and the lovely blue sky. It's a bit windy today, but we've got to go. From the moment it was dropped off on my driveway, I knew that this was going to be the most challenging and biggest builds that we've done on the channel so far.
The automotive world had seen many unbelievable rebuilds before, but nothing could prepare enthusiasts for what happened after Bugatti finally responded to Mat Armstrong's most controversial project. For months, millions of viewers had watched the British YouTuber take on a challenge that many believed was impossible. Sitting in front of him was not an ordinary damaged car. It was a Bugatti Chiron Persport, one of the most exclusive and expensive hypercars ever created. The vehicle had already been declared a total loss. Bugatti had effectively shut the door on its future by blacklisting the car and making repairs almost impossible through traditional channels. To most people, the story should have ended there. A crashed hypercar worth millions of dollars would normally disappear into storage, become a source of spare parts, or spend the rest of its life hidden away from public view. But Mat Armstrong saw something different. He saw a challenge. As he began taking the car apart piece by piece, viewers expected to witness an impressive rebuild. What they did not expect was a project that would start a discussion reaching far beyond one damaged Bugatti. Every episode revealed something new. Mat showed that many parts were not as mysterious as people believed. He demonstrated that some repairs considered impossible could actually be completed by skilled mechanics outside the factory. He challenged assumptions that had existed in the hypercar world for years. The project became bigger than entertainment. It became a test of who truly controls modern vehicles, the owner who buys them or the manufacturer who builds them. The tension reached another level when the story attracted the attention of Bugatti itself. Most people expected lawyers, warnings, or complete silence from the company. Instead, something surprising happened. Mate Rimac, the man leading Bugatti into the future, decided to engage directly rather than attacking the project. He opened a conversation. For many viewers, this was already a shocking development. A company known for exclusivity was suddenly speaking publicly about a rebuild taking place inside a small workshop. It felt as though the wall separating ordinary enthusiasts from the hypercar elite was beginning to crack. But while the internet focused on the public exchange between Mat Armstrong and Bugatti, another story was quietly developing in the background. It was a story involving technology, engineering, and the future of vehicle design itself. During the rebuild, discussions began to emerge about advanced manufacturing methods. People talked about 3D scanning. They talked about digital modeling. They talked about producing replacement components without relying entirely on factory supply chains. At first, these conversations seemed like small details connected to the rebuild, yet they hinted at something much larger. The automotive industry was changing. Artificial intelligence was beginning to influence nearly every stage of vehicle development. Engineers were using AI systems to analyze structures, optimize components, predict weaknesses, and create designs that would have taken human teams months or even years to develop. Suddenly, the question was no longer whether a damaged Bugatti could be rebuilt. The real question became whether future vehicles might be designed, repaired, and improved using technologies that could challenge traditional manufacturers in ways never seen before. Mat Armstrong may not have set out to expose this transformation. His goal was simple: say a Bugatti that everyone else had given up on. Yet every step of the journey revealed a deeper truth. The battle was not only about one car. It was about the future relationship between technology, manufacturers, independent mechanics, and owners. As Bugatti responded to the rebuild, and the world watched the drama unfold, a much bigger revolution was beginning to emerge. And at the center of that revolution stood a force that could reshape the automotive industry forever: artificial intelligence. The moment Bugatti entered the conversation, the entire rebuild project changed. Until then, many people had viewed Mat Armstrong's work as an entertaining challenge between a determined YouTuber and an extremely expensive damaged car. But when one of the most prestigious automotive brands in the world publicly acknowledged what was happening, the rebuild became something much larger. Millions of people who had never watched a Mat Armstrong video before suddenly became interested. Automotive forums exploded with discussions. Social media users debated whether Bugatti's policies were justified or whether independent mechanics deserved greater freedom to repair vehicles they legally owned. The story had evolved into a global conversation about ownership, technology, and the future of engineering. What made the situation even more fascinating was the way Matt approached the challenge. He did not present himself as a corporate rival. He did not claim to know more than Bugatti's engineers. Instead, he approached every problem with curiosity. When he encountered damaged parts, he studied them. When he faced obstacles, he searched for solutions. This approach resonated with viewers because it reflected something people admire: persistence. Many automotive enthusiasts saw themselves in Matt. They understood what it meant to tackle a difficult project and refused to quit simply because someone else said it could not be done. As the rebuild continued, one topic kept appearing again and again: modern manufacturing technology. Years ago, replacing a damaged component often meant finding an original factory part or abandoning the repair entirely. Today, however, technology has changed the rules. Engineers can scan damaged parts with incredible precision. Computers can generate digital models in a matter of hours. Advanced machines can manufacture components with levels of accuracy that once seemed impossible. What was especially interesting was how artificial intelligence was beginning to accelerate these processes. Instead of spending weeks analyzing a design, engineers could use AI systems to identify weaknesses, suggest improvements, and optimize structures faster than ever before. This raised an uncomfortable question for many traditional manufacturers. If independent workshops could access powerful digital tools, how much control would factories continue to have over repairs? For decades, companies maintained authority by controlling parts, information, and specialized knowledge. That system worked because the average repair shop lacked the resources to challenge it. But technology was changing that balance. Every year, advanced software became more accessible. High-quality scanners became more affordable. Manufacturing equipment became more capable. Most importantly, artificial intelligence was making complex engineering knowledge easier to apply than ever before. While many people focus on the dramatic images of a Bugatti being split apart inside a workshop, industry experts noticed something deeper. They saw evidence of a larger transformation taking place across the automotive world. AI was no longer limited to research laboratories or giant corporations. It was becoming a practical tool available to smaller businesses, engineers, and innovators. Some systems could analyze thousands of design possibilities in minutes. Others could predict how a component would behave under extreme stress before it was ever manufactured. These capabilities were once available only to major automotive companies with enormous budgets. Now they were slowly becoming accessible to a much wider audience. For manufacturers, this presented both opportunities and challenges. On one hand, AI could help create stronger, lighter, and more efficient vehicles. On the other hand, it could reduce dependence on traditional factory control systems. Independent specialists might gain the ability to develop solutions that were previously impossible without corporate support. The relationship between manufacturers and owners could change dramatically. Instead of being locked into a single repair pathway, vehicle owners might one day have access to a network of highly skilled specialists equipped with advanced AI-powered tools. As viewers watched Mat Armstrong continue his rebuild, many did not realize they were witnessing more than a restoration of a damaged hypercar. They were watching a preview of a future where technology could challenge long-standing industry traditions. The Bugatti project had become a symbol of something much bigger than one workshop, one mechanic, or one car. It was becoming a glimpse into a future where knowledge, creativity, and artificial intelligence could reshape the rules that had governed the automotive industry for decades. And the deeper people looked, the more they realized that the biggest story was only beginning to reveal itself. As the rebuild moved forward, the project entered its most important phase. Finding damaged parts and identifying problems was one thing. Actually bringing the Bugatti back to life was something completely different. This was where many people expected the project to fail. Critics argued that taking a Chiron apart was easy compared to putting it back together correctly. After all, this was not a family sedan or a sports car built in large numbers. It was one of the most advanced hypercars ever produced, powered by a legendary 16-cylinder engine capable of generating enormous performance. Every component had been designed to operate within incredibly precise limits. One mistake could turn a promising rebuild into a financial disaster. Yet Mat Armstrong continued to push forward. Each challenge seemed to reveal another layer of complexity hidden beneath the carbon fiber bodywork. Electrical systems had to communicate perfectly. Cooling systems had to function under extreme conditions. Structural components had to maintain strength while supporting immense forces. Viewers watched as countless hours of work went into solving problems that most people would never even notice. This was one of the reasons the series became so addictive. Every episode offered a mixture of suspense and discovery. Success was never guaranteed. At any moment, a new obstacle could appear and threaten months of progress. What made the situation even more remarkable was the growing role of digital technology in modern engineering. In the past, mechanics often relied primarily on experience and physical tools. Today, digital information has become just as important as wrenches and lifts. Engineers use computer simulations to predict performance. Designers use advanced software to model components before they exist. Manufacturers use massive databases containing technical information about every part of a vehicle. Increasingly, artificial intelligence is becoming the force connecting all of these systems together. AI can process enormous amounts of engineering data far faster than humans. It can compare thousands of design possibilities and identify solutions that might never occur to a person working alone. In the automotive industry, this capability is transforming everything from vehicle development to manufacturing and maintenance. Some AI systems can analyze how airflow moves around a car and suggest aerodynamic improvements. Others can predict which components are most likely to fail over time. Some can even help engineers create lighter structures without sacrificing strength. These are not distant future concepts. Many manufacturers are already using these technologies every day. The connection to Mat Armstrong's rebuild became clearer as the project progressed. Every time he investigated a damaged component, searched for alternatives, or explored new manufacturing methods, he was operating within an environment increasingly shaped by digital innovation. Independent workshops around the world were beginning to adopt technologies that were once available only to giant corporations. High-resolution scanners, computer-aided design software, advanced machining equipment, and AI-powered engineering tools were becoming more accessible with each passing year. This shift was quietly changing the balance of power within the automotive industry. For decades, manufacturers maintained a significant advantage because they possessed exclusive knowledge. They had the engineering data. They controlled the supply chains. They held the technical information required to repair complex vehicles. But technology was slowly reducing those barriers. Knowledge that once existed behind factory walls was becoming easier to understand and apply. Skilled individuals equipped with modern tools could now solve problems that previously required entire corporate departments. The implications were enormous. If this trend continued, the future of vehicle ownership could look very different from the past. Many enthusiasts began to see Mat Armstrong's Bugatti project as more than an entertaining rebuild. It became a symbol of a larger movement. The story represented curiosity, overcoming limitations. It represented innovation, challenging tradition. Most importantly, it demonstrated that expertise was no longer confined to large organizations. A determined mechanic, supported by modern technology and a global audience, could influence conversations that reached the highest levels of the automotive world. As excitement surrounding the rebuild continued to grow, another realization started to emerge. Artificial intelligence was not merely helping engineers design better cars. It was beginning to reshape the entire relationship between manufacturers, mechanics, and owners. The same technology that could help Bugatti create the next generation of hypercars might also empower independent innovators to repair, improve, and understand those vehicles in ways that were once unimaginable. And as this reality became impossible to ignore, the automotive industry found itself standing at the edge of one of the biggest transformations in its history. By this point, the Bugatti rebuild had become one of the most talked about automotive projects on the internet. Every new video attracted millions of views, and every update sparked fresh debates among enthusiasts, engineers, and industry experts. What began as a damaged hypercar sitting in a workshop was now influencing conversations across the entire automotive world. People were no longer asking whether Mat Armstrong could repair the car. Instead, They were asking what the project revealed about the future of the industry itself. One of the biggest surprises was how many assumptions were being challenged along the way. For years, hypercars have been surrounded by an almost mythical reputation. Manufacturers carefully build an image of exclusivity around these machines. Owners often believe that only factory-trained specialists could truly understand them. Many assumed that if a major component failed, there was no alternative except returning to the manufacturer and paying whatever price was demanded. The Bugatti rebuild forced people to look at those assumptions more critically. As Matt and his team examined various systems throughout the car, they discovered that even the most exclusive vehicles still follow the same engineering principles as any other machine. They may use more advanced materials, more powerful engines, and more sophisticated electronics, but they are still built from parts designed by engineers and assembled by people. This realization may seem obvious, yet it had a powerful effect on viewers. The project removed some of the mystery surrounding hypercars and replaced it with understanding. At the same time, the automotive industry was experiencing rapid changes driven by artificial intelligence. Major manufacturers were investing billions of dollars into AI research. Some companies were using machine learning systems to improve battery performance. Others were developing AI-powered quality control systems capable of identifying manufacturing defects with incredible accuracy. Advanced algorithms were helping engineers reduce weight, improve efficiency, and increase reliability. In many ways, AI was becoming one of the most important tools in modern vehicle development. What made this especially interesting was the fact that AI was not limited to large corporations. Independent engineers and smaller companies were beginning to use similar technologies. Software that once required enormous budgets was becoming more affordable. Cloud computing allowed smaller teams to access powerful processing resources without owning expensive hardware. AI-assisted design tools could help users solve engineering problems that would have been far more difficult only a few years earlier. This democratization technology was one of the most important trends shaping the future. The rebuild highlighted exactly why this mattered. Imagine a future where an independent workshop can scan a damaged component, use AI to analyze its weaknesses, improve the design, and manufacture a replacement part that performs even better than the original. Such ideas might have sounded unrealistic in the past, but they are becoming increasingly possible. In some industries, these processes are already happening today. Aerospace companies, medical manufacturers, and advanced engineering firms are already using AI-assisted design techniques to create stronger and more efficient components. For traditional manufacturers, this creates both excitement and uncertainty. On one hand, AI allows companies to build better products than ever before. On the other hand, it reduces the advantage that comes from controlling specialized knowledge. Information that once existed only within corporate engineering departments can increasingly be recreated, analyzed, and improved by skilled individuals using advanced software tools. The gap between factory engineers and independent innovators is shrinking faster than many people expected. This is one reason why the response from Bugatti and Mat Armstrong attracted so much attention. Rather than fighting against a changing landscape, Armstrong appeared willing to engage with it. He recognized that transparency, collaboration, and openness were becoming more valuable than secrecy. Modern audiences appreciate authenticity. They want to understand how products are built. They want access to information. They want to feel connected to the engineering process. The success of Mat Armstrong's rebuild demonstrated exactly how powerful that desire has become. As the Chiron moved closer to returning to the road, another truth became clear. The project was no longer just about proving that a damaged hypercar could be repaired. It was about demonstrating that technology was changing the relationship between manufacturers and enthusiasts. Artificial intelligence, advanced manufacturing, and digital engineering were creating opportunities that had never existed before. The old barriers were beginning to weaken, and a new era of automotive innovation was taking shape. The question was no longer whether change was coming. The question was how dramatically it would reshape the industry in the years ahead. As public interest in the rebuild continued to grow, many people began looking beyond the damaged Bugatti itself and focusing on the man leading the project. Mat Armstrong had already built a reputation for taking on vehicles that others considered impossible to save. Over the years, viewers had watched him rebuild supercars, luxury vehicles, and heavily damaged performance machines. But the Chiron project felt different. This was not simply another repair. It represented a direct challenge to one of the most powerful symbols of automotive exclusivity. Every step forward felt like a victory not only for Mat, but also for millions of enthusiasts who believe that knowledge and determination should matter more than corporate barriers. The reason this story connected with so many people was simple. Everyone loves an underdog. Throughout history, audiences have been drawn to stories where ordinary individuals challenge powerful institutions. Whether in sports, business, technology, or engineering, these stories capture attention because they reflect something universal. People admire courage. They respect persistence. They enjoy seeing someone refuse to accept limitations imposed by others. In many ways, the Bugatti rebuild followed this classic pattern. On one side stood a global manufacturer with immense resources, engineering expertise, and decades of prestige. On the other side stood an independent creator working from a workshop, supported by a camera crew, his family, and a loyal audience. What made the situation even more compelling was the speed at which technology was evolving around them. Artificial intelligence was beginning to influence nearly every aspect of modern life. It was helping doctors diagnose diseases, assisting scientists with research, improving logistics networks, and transforming industries around the world. The automotive sector was no exception. AI systems were becoming increasingly important in vehicle design, production, testing, and maintenance. Companies that embraced these tools gained significant advantages in efficiency and innovation. Those that ignored them risked falling behind. Many experts believe the next major revolution in the automotive industry will not be a new engine, a new fuel type, or even a new vehicle platform. Instead, it will be the integration of intelligent systems into every stage of the automotive life cycle. AI can analyze enormous amounts of data collected from vehicles operating in real-world conditions. It can identify patterns that humans might overlook. It can predict failures before they occur. It can recommend maintenance schedules tailored to individual vehicles. In some cases, it can even suggest engineering improvements based on millions of simulations performed in a fraction of the time required by traditional methods. This growing influence of AI raised an interesting possibility. What if the future mechanic is not working alone? What if advanced software becomes a partner in the repair process? Imagine a system capable of scanning a damaged vehicle and instantly generating a detailed repair strategy. Imagine software that can identify every affected component, estimate structural impacts, suggest replacement methods, and predict long-term reliability. Such capabilities could dramatically reduce repair times while improving accuracy. For independent workshops, these tools could become as important as traditional equipment. The Bugatti project offered a glimpse into this future. While much of the rebuild relied on practical experience and mechanical skill, it also highlighted the increasing importance of digital tools. Modern repairs often involve software diagnostics, digital measurements, and advanced engineering analysis. As artificial intelligence becomes more powerful, these capabilities will continue expanding. The line between mechanic and engineer may become increasingly blurred. Future workshops could combine hands-on craftsmanship with AI-assisted decision-making in ways that seem extraordinary today. For enthusiasts,